Okay, guys, you are taking on theoretical probability, okay, which is a little different than the empirical probability, which your partner will be explaining to you, hopefully. Hopefully you guys understand what's going on, okay? You are going to have to explain the theoretical probability to them, okay? In either case, whether you're empirical or theoretical, we are trying to understand those types of probability so that eventually, meaning when we come back from spring break, you will be able to kind of insert this knowledge into our actual probability and statistics unit so that you can actually then kind of derive, okay, decisions and outcomes and evaluate those decisions and outcomes based on the probability that you've got. Okay. For us, you guys dealt with theoretical probability before. Most of the stuff that I'm going to say is going to be at least hopefully familiar to you. So I'm not going to spend too much time with the definitions of things. But we do need to remember that theoretical probability is the number of ways that an event, I should say event, boom, right there, can occur, okay, divided by the total number of outcomes. So if we take a look, each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? I know, you're angry with me. I'm making you remember English, right? Consonant, vowel, vowel, consonant. Just remember, we've got consonants and we have vowels. These are the consonants, right? P-R-B-B-L-E, okay? So we need to talk about two things. First of all, we have a total of 8 letters, right? Okay, we have a total of 8 letters, and if we look at that, we have 5 of them that are consonants. Okay. 5 of them are consonants. Okay. We want to know the probability that if I select that card, I'm going to pull a consonant. Well, the 8 letters, that is our sample space, total number of outcomes. And the 5 consonants, that's what we want. Remember, theoretical probability deals with what do we want out of how much do we actually have. Okay? So if I'm looking at this, I'm going to put consonants over total letters. Well, we have 5 consonants over total letters. So we've got consonants over our sample space. We've got a probability of 5 out of 8, which is 0.625. And written as a percentage, it is 62.5%. So that means there's a 5/8 chance, a 0.625 chance, or a 62.5% chance. When you're writing probability, you can write it as a fraction between 0 and 1, a decimal between 0 and 1, or a percentage. Okay? So simple enough to start with. Just a nice little refresher saying, hey, guess what? We've done this before. We can kind of remember what's going on. If we take a look at the next problem, a little more complicated. Not too bad, just a little more. 2 number cubes, one red and one blue, are rolled. What is the probability that the difference between the 2 numbers is 4? Okay? So I'm looking at probability that the difference is 4. Well, here's the thing. I have to figure out my sample space first. Some of you may have already thought about the fundamental counting principle, which we have 6 numbers on the first cube and 6 numbers on the second cube. So we have 6 times 6, or 36 different outcomes. And that's what we do have. But we also have this lovely little chart that's going to help us kind of organize what we're looking for and what we need. If you notice, okay, I have 1, 2, 3, 4, 5, 6 heading that way. And then I have 1, 2, 3, 4, 5, 6 heading that way. Those are our numbers, our number cubes, obviously red and blue. So we could have a red 1 and a blue 1 when we roll them. We could have a red 1 and a blue 2 when we roll them. Okay. We could have a red 1 and a blue 3 when we roll them. And so basically this is all the combinations. So we could also over here we could have a, we could have a 3 and a 6. Right? We could have a 4 and a 2, a 4 and a 3. We can have a 4 and a 4. We can have, oh, sorry about that. We can have a 4 and a 5, a 4 and a 6, right? And you could be writing all this on your paper so that you have it because you will need it, all right? So we can have a 5 and 2, and then all these can be filled in with 5s. We'll take care of that first, right? Then we'll have a 3, a 4, another 5, another 6, and then of course all these right here, okay? 3 there, 4, 5, and a 6. And so if you look right here, that is our total number of possible outcomes. We've got 36 possible outcomes. Those are the different scenarios. This is asking us difference of 4. Difference of 4, which means I have to go through my scenarios and figure out which ones I want, which ones I don't want. Obviously, if I take a 1 minus a 1, I get a 0. That's not a difference of 4. So that's gone. 1 minus 2 or 2 minus 1, same thing. Okay? If I look at this, 3 minus 1, 2 minus 2, 3 minus 1, those are gone. Okay? 4 minus 1, that's a difference of 3. This is a difference of 1. This is a difference of 1. That's a difference of 3. Okay? Hey, 5 minus 1. That'll work, right? We want that. And then we've got to go back to 4 minus 2. Nope. No, no, no. Right? We're just looking to see what the actual difference of the two numbers is. Okay? I'm going to look here. 6 minus 1, that's a difference of 5. Not going to work. Okay? 5 minus 2, difference of 3. 4 minus 3, nope. Hey, guess what? I'm hoping that at that point, somebody would have called me on my mistake. I need that one too, guys. So glad you were paying attention. All right, so we need 5 and 1. There we go. All right, 4 and 3. Nope. 5 and 2. Nope. 6 and 1. Nope. Okay. Hey, we got a 6 and a 2. When we subtract those, we get a 4. And just to be safe, I'm going to go down here and actually circle that one to go as well. And then if I look, the rest of them in this diagonal, not going to work, not going to work, not going to work. If I look down here, the 6 and the 3 that I'm tapping at right there, not going to work. Nope, nope, and a nope. Basically, everything else that we look at, that's going to be a difference of 2, that's a difference of 0, difference of 2, difference of 1, difference of 1, difference of 0. So now that I've crossed off what I don't need, I can take a look at what I've circled, and I have got 5, 1, 5, 1, 6, 2, 6, 2. So I basically just have those 4 options. So when I go back to do this, I have 4 desirable outcomes, the ones that I want, where the difference is actually 4. Okay? And that's over, the total outcomes is 36. Right? I had 36 possible outcomes in my sample space. And of course, I will reduce this. Always reduce your fractions, please. Okay, so it's 1/9. And then as a decimal, it is 0.1111. Or as a percent, it's about 11.11%. Okay? So there's about an 11% chance that if I do this, if I roll the 2 number cubes, I'm going to get a pair of numbers where the difference is 4. All right, guys, onward and upward. Onward and upward. Here we go. Okay. We're going to use the same sample space. We want to know now, what is the probability that the sum of the 2 numbers, is greater than 6? Okay. So we are using the sample space that we had before, and yes, it is through the miracle of television that I bring that to you. Not really, if you know, you've seen that before. Okay. So we've got the same sample space, and what I want to do now is I want to add my numbers. I want to take this 1 plus 1. When I take that, I get a 2. That's not going to work. Okay? The sum here, that's going to give me a 3. That's a 3. Not going to work. 3 plus 1 right there, that's a 4. Not going to work. I got a 4. All right? So basically on your diagonals, you can see that the sums On your diagonals are basically everything you got. Now, if I look here, 5 plus 1, that gives me a 6. Problem is, I wanted greater than 6. So it's not allowed to be equal to 6. So it's gone, basically that whole thing. Now, everything past that, you look at everything past that, I got a 6 plus 1 there, I got a 7. So basically this whole diagonal here, right, is going to be all of it. And then the next diagonal, because that's all going to add up to 8. Then those diagonals, basically everything that I just circled in green. All of those diagonals afterward sum greater, okay, than 6. So what I really need to do then is kind of count up what I have. And when I do count up what I have, I actually end up having a total of 21. Okay, 21 of them are greater than 6. 21 of those pairings are greater than 6. That's 21 out of 36. Okay, 21 out of 36. And of course, when I reduce that, I'll get a 7 out of 12. And when I actually go and get my decimal, I get a 0.5833, which is a 58.33%. Okay? All right, guys, almost done. Okay? The very last one's still using the same sample space. Still using that same sample space. So now, though, I want to know what the probability that I will have a difference between the two numbers that is less than 2. So I want a probability that our difference less than 2. I got to do the same thing. It's just simple math, adding, subtracting, figuring out those differences. Okay? When I take the 1 minus the 1, I get a difference of 0. That's definitely going to work. 2 minus 1 works. That one will work. Okay? If I look at this as 3 minus 1 right here, that's not actually going to work because 3 minus 1 is 2, and I want it to be less than 2. So that's out. But we got this in the middle. That'll work. 1 minus 3 or 3 minus 1 is out. 4 minus 1 is out. Okay, so that means this is out there. Then I can look in the middle. 3 minus 2, 2 minus 3, those will both work. Looking at the edges again. 5 minus 1, not going to work. 4 minus 2, not going to work. My 3 minus a 3 will work. And then, of course, these two on the edges. And you'll start to see patterns as you are doing this. Okay? Your outsides, not going to work. 5 minus 2, not going to work. But if you look, your 4 minus 3s, those will work. 6 minus 2, not going to work. 5 minus 3 is actually just 2, remember, so we want something less than 2. So that means this 4 minus 4 will work. We got a 6 minus 3 that's not going to work. And then, of course, in the middle, 5 minus 4, those work. Okay, 4 and 6, that's not going to work. That's exactly 2, and we want it to be less than. We got a 5 here. I'm sorry, a 5 minus 5 there. 6 minus 5, 6 minus 5, that'll work. And then the 6 minus 6 works. And of course, I'm just going to count up the things that I circled. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got 16 of those. 16. So we got a 16 out of 36, which works. Okay, those are what we want. And this is 4 over 9, which is 0.4, repeating. Right? And so it's about 44%. We got a 44% chance that when we roll those two die, we will get a combination of numbers that have a difference that is less than 2.